Can we compute a contour integral if a branch cut passes through our contour? Well, yes we can, but we need to be really careful to avoid the branch cut. We need to take appropriate limits. We will see an example of such an integral in this video. So, what will be our c? Our c will just be the unit circle, t between minus pi and pi, so we go along the unit circle, all around. And our z, f of z will be dangerous. Our f of z will be z to the power minus 1 plus I. So, you know power function, so you know a log, so you know danger, because you need a branch cut. In this case, we define it as follows, as e to the power minus 1 plus I times the log of z, where we will take the principal value of the log of z. So that means the ln of the modulus of z plus I times the argument of z, which is between minus pi and pi. That's how we define our function. And you'll see that we have a problem there, because we have the branch cut over there, which we'll need to avoid. So what do? We take a set of t1, which is slightly below the branch cut, and a set of t2, which is slightly above the branch cut. And then we will integrate from t1 to t2, so we avoid the branch cut, and in the last step we will take the limit. So we are not onto the branch cut, we are always above or below, and in the last step, also in the limit, you stay away from the branch cut, you just get arbitrarily close. So that's the strategy. Well, how does it work? So here we have our strategy. We take the integral from t1 to t2, where everything is nice, and then in the last step the limits. So if we have z equals e to the power it, the log of z is just it, as long as you are really between minus pi and pi, which is now the case because our t is between t1 and t2. So our f of z becomes e to the power minus 1 plus I times this log, so e to the power minus 1 plus I times it becomes e to the power minus it minus t. Then it becomes really nice because the dz becomes I times e to the power it dt. It's over here. So here the function, and you see some factors are going to cancel out here. So you are left with an I times e to the power minus it dt, and you can integrate it directly to minus I times e to the power minus it. Then we have to include the boundaries. Integral f z dz. We have our antiderivative minus I e to the power minus it, and evaluate between t1 and t2, and then we take the limits in the last step. So first plug in the boundaries, so you get a minus I, just take it in front, times upper boundary minus lower boundary, and then taking limits is no problem because there's no danger in this limit, so you can just plug in the values. So you get upper boundary minus lower boundary, and you can make the answer a bit nicer if you take in the minus sign first and multiply by 2 and divide by 2, so you get a 2i and you divide by 2, because the second term you recognize that's the sine hyperbolic of pi, so your final answer will be 2i times the sine hyperbolic of pi. So you see, if you have some branch cut somewhere, you still can do contour integration, but you just have to be careful. You cannot enter the branch cut, so you do something like taking limits, as in this example.